force, circular motion, friction,
momentum. Wow! The linemen set up for the play. They pound their feet and apply the force on each other. The offensive line is trying to keep the defensive line from getting to the quarterback. Force equals mass times acceleration, and these linemen have great mass and a very quick foot speed. When we see a double team, the two offensive linemen are applying more force on the one defensive lineman, which makes that silly defender go bye-bye!
You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk.
Wow! I love to see quarterbacks run the ball. Here we see the quarterback run in a quarter circle from facing the sideline to the goal line. As he runs, there's a centripetal force pulling him to the inside of the turn. He also may feel a bit of what is called centrifugal force, which isn't a force, but a feeling of the effects of inertia. Centripetal force is equal to mass times velocity squared over the radius of the circle one is running in. A great formula, if you ask me. The quarterback obviously has a mass and is running at a velocity. The curve he is running at has a raised radius. And when those variables are plugged into the formula, we can figure out the force that is pulling this handsome quarterback inward. Oh boy, I love football.
You're a jerk. You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk.
Wow! I love this play when young Reggie Bush uses friction and the mew of his shoe to fly for an 81-yard touchdown. This man knows how to use his physics. It takes a certain force to drag Reggie's shoe on that field, and he has a certain mass that is pushing that shoe on the field. When you divide the force over the mass, we get the mew of the shoe. Reggie uses his mew to sprint very fast. He applies lots of force backward on the ground for every step, and the ground pushes back on his feet, allowing him to move forward. When Reggie wants it, Reggie takes it, and he scores!
You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk. You're a jerk.
I know.
You're a jerk.
Wow! If you're like me, you love to see collisions in football. When one player tackles another player, the physics involved just tickles me pink. Momentum is a key aspect in collisions. Here we see a man running the ball with momentum and a safety with lots of momentum running at each other. The safety knows how to transfer his momentum into a great hit as he just decks the receiver. Momentum is equal to mass times velocity. Both players had similar masses, but the safety had much more velocity and a good position. When collisions happen, objects often bounce off of each other. In this lovely situation, we see that because of the angle of the collision, their momentums carried them to bounce off to opposite sides of each other. The receiver was knocked out cold.
You're a jerk.
I know.
You're a jerk. 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 You're a jerk.
No boy.
You're a jerk. You're a jerk.
No boy.
You're a jerk. You're a jerk.
No boy.
You're a jerk. You're a jerk.
No
You're
boy.
a jerk. Jerk. Jerk.
Jerky.
Jerk. Jerk. Jerk.
Jerky.
Wow, 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 wow.
You're a jerk.